Okay, today we're going to talk about how we factor trinomials, and this is part of AA20, learning how to factor algebraic expressions completely, including trinomials with lead coefficient of 1. So in particular, we're going to talk about these trinomials with lead coefficient of 1. Okay, so our vocabulary is factor, sum, difference, and coefficient. And this follows chapter 11, section 7. I've split this section into two parts. Right. So the first thing we want to do is define what lead coefficient means. Okay, lead coefficient is the coefficient of the term in the polynomial that has the greatest exponent. So since this is x squared here, that has the largest exponent. So 2 is considered the lead coefficient in this polynomial. The constant is the numerical term in the polynomial. It is not attached to a variable. But remember, that's always, we can consider this as being multiplied by x to the 0 power, but we don't often write that. So as it seems in the polynomial, as it's written, the constant is not attached to a variable. Okay, so 2 is the constant in this polynomial. So the first thing is we're going to look at these trinomials that have a lead coefficient of 1. So right now, the coefficient of the leading term is the term with the highest exponent. The coefficient of this term is 1. Okay, we can tell that it's 1 because we don't write it there. All right, so these are special trinomials that we're going to look at. And what we want to do is we want to factor these trinomials. So we learned yesterday how we multiply binomials mentally. So, and we also know that factoring is the opposite of multiplication. Oftentimes, it's factoring requires you to undistribute something. So usually when I have two binomials like these, and I ask you to multiply them, there's a distribution process that we use. First we take the x and multiply that through, and that would be x squared plus 2x. And then we take the 3 and distribute it to the other parts of the there, and we would know that these two things multiplied back gets you x squared plus 5x plus 6. Now what we're doing today is we're taking the trinomial that's already been multiplied and working backwards to find the binomial factors. Okay, so if we look at the way that these two binomials were multiplied, remember that this is your f, this is your o, this is your I, and this is your L term. Then the o and the I term added together to get one term in the middle there. The coefficient of that term is also the sum of those two numbers. And the constant there is the product. Okay, so if I have this trinomial in question 1, and I'm trying to figure out what binomials were multiplied in order to get that trinomial, what I want to do is I want to think of how I got 12 and how I got -7. Okay, now I'm going to use something called the x factor. It's just a little teaching device that some teachers use to show how to find the binomial factors. The x factor is you write a big X, okay, and you write the coefficient of the middle term in the top part of the x, so that should be -7, and you write the constant at the bottom. And then you ask yourself, what two numbers add to -7 and multiply to 12? So what two numbers add to -7 and multiply to 12? So we know, we can think about 3 and 4 for a minute. Okay, the product of 3 and 4 is 12, but the sum of 3 and 4 is +7. So actually, if I just make this -3 and -4, we know that -3 plus -4 is -7. Okay, so we know that -3 plus -4 is -7. So that's going to be that. And we know that -3 times -4 is going to be +12. Okay, so those are the two numbers I'm looking for. So the way that I put them back in the binomial is, let me make this a little neater. X, or that should be A, sorry. So here we have these two binomials that were multiplied to get the trinomial that we see here, a squared minus 7a plus 7. And we know that the constants are going to be -3 and -4. And I'm not going to think of them as negative. I'm going to write that as the operation, -3 and -4. And what multiplied to get a squared? Well, that would have been a and a. And if we use what we learned yesterday to multiply these two binomials mentally, we would see that that was a squared, and then negative 3 plus negative 4 would be minus 7x, and then negative 3 times negative 4 would be plus 12. Okay, whoops, I keep putting x there, and this really should be a. Now, I keep saying that I'm sort of switching around. I say negative 3 times negative 4 is positive 7, and I change that into positive 12, and I change that into adding 12. So I know that I'm switching around the terminology for the sign of the number and the operation. And that's what I sort of want you to do in order to do this mentally. Okay, if these are positive 12, then I want you to think of that as plus 12 in the trinomial. So the answer to this question, well, the question is, how do I factor that trinomial? And the answer is, it's those two binomial factors. Okay, so let's try another one. Y squared minus 6y plus 8. So let's again write the x factor here. I'm going to write negative 6 on the top. That's the coefficient of the middle term. I'm thinking of it as a negative 6, even though it's subtracting 6y. I want to think of that as a negative 6. And the constant is positive 8, so I'm going to write 8 here. Okay? So I need two numbers that add to negative 6 and multiply to negative 8. So the fact that they add to negative 6 and multiply to a positive number, they must both be negative. Right? Because only two negatives add to a negative and also multiply to a positive. So I want to think of two things. So think of factors of 8, so 4 and 2. So let's make it negative 4, negative 2, and then check ourselves. Okay, negative 4 plus negative 2 is negative 6. And their product is positive 8. So we have them here. So the way that you rewrite them is y. Okay, so each binomial is going to have a y. That's why you have a y squared right there. And we're going to write that negative 4 as minus 4, and the negative 2 as minus 2. Okay? And if I were to multiply that out mentally, I would get y squared minus 6y plus 8. Right? We multiplied it mentally. It's the type 2 binomial that we showed in the lesson yesterday. Okay, so the answer to number 2 are those two binomials. Okay, for number 3, let's try the x factor again. All right, so let's put 10 up here and 25 here. At this point in the video, you might want to pause it and see if you can do these on your own. So we have 10. We're looking for two things that add to 10 and multiply to 25. So that would be 5 and 5. So here we have z. Let's write z in the other one. Okay, and so these are positive 5, so I'm going to write that as plus 5 and plus 5. Okay, but we've arrived at two binomials that are the same, so actually we could reduce how we notate this by using that notation, right? Because it's the same binomial squared. Okay, so that's the full answer there for number 3. Oops, I'm missing number 4 for some reason, but that's okay. So for number 5, again, let's write the x factor. We write the coefficient of the middle term up here and the constant down here. I'm looking for two things that multiply to 16 and add to 10. So that must be positive 8 and positive 2. Okay, so I should have x here and x here. We can go plus 8 and plus 2 right there. And remember, that's also, if you had written it like this, that's identical, because remember, there's multiplication in between there, and multiplication is commutative. So you can write the factors in any order that you want, right? This is factor number 1. This is factor number 2, and I can reverse their order because it's multiplication is commutative. So either this is your answer or the top is your answer. Okay. All right, for number 6, we have negative 10 and positive 16. So this is almost identical to number 5, except the variables are different, and the sign of the middle term is different. Okay, so since there's a negative 10 and a positive 16, we know that both factors are negative. Okay, you might want to ask yourself why that is and pause the video. Why do I know at this point that both factors are or both numbers that I'm looking for in the x factor are negative. And the answer is because only two negative numbers add to another negative number, right, and multiply to a positive number. So here I'll have negative 8 and negative 2, because negative 8 plus negative 2 is negative 10. Negative 8 times negative 2 is positive 16. So we have y minus 8 and y minus 2. That's the answer there. Okay, I put these 7 through 10 all on the same page so that you can see. So generally I use the same variable d, and I have the same constant at the end, negative 42. Only the coefficient of the middle term changes from 7, 8, and 9, and I put c on 10, but really it's almost the same thing because the last constant here is all negative 42, but the coefficient of the middle terms here are all different. Okay, so we'll see how that results in, we're going to have 4 different pairs of binomials for 7, 8, 9, and 10. Okay, so let's go do the x factor here, negative 42 on the bottom. And my coefficient of my middle term here is 1. So remember the coefficient when it's not written is implied that it's 1. So I'm looking for 2 factors of negative 42 that add to positive 1. Okay, so they have to be fairly close to each other, and the larger factor of negative 42 has to be positive. So I would think that it would be positive 7 and negative 6. Let me check myself here. That's positive 1, and this times, it's negative 42. So that must be what it is. So we have d plus 7 and d minus 6 here. Oops, d minus 6. Okay. Now, number 8 is different because instead of, so there's still a negative 42 here. Okay. There's still a negative 42, but the middle, the coefficient of the middle term is negative 1 instead of positive 1. So instead of 7 and negative 6, let's make it negative 7 and positive 6. Okay? And so negative 7 plus 6 is negative 1, and their product is negative 42. So here we'd have d minus 7 and d plus 6. Okay? Now for this bottom one, again, negative 42 is still the constant, but here their sum is negative 41. So we want to think of factors of negative 42 that add to negative 41. So I'm going to guess it's negative 42 and positive 1. Let me think about this for a second. I have negative 42 plus 1. I know that's negative 41. And their product is negative 42. So that's what it is. So it's d minus 42 and d plus 1. Okay. Now we have this last one here. Again, negative 42 and 19. So I know that the bigger factor is positive. Okay, so this 42 has 21 and 2 as factors, so that must be what we have to work with. We have to make one of them negative because the product is negative. So one of them must be negative. And exactly one of them must be negative because if both of them were negative, then the product would be positive. So we're going to make 21 positive and negative 2 here because negative 21, positive 21 plus negative 2 is positive 19, and their product is negative 42. So we'd have C plus 21 and C minus 2 here. Okay? And then I have one more page where they're all the same constant, but I've varied the coefficients here. So you might want to pause it and see how quickly you can do these and then come back to it. So let's just keep, so I have 60 here and negative 17. Okay, so that's going to have something to do with 20 and 3. So let's make the 20 negative and this positive, and that's it. So we have x minus 20 and x plus 3. Just make sure. Negative 20 plus 3 is negative 17, and their product is 60. Oh, actually, no, their product wouldn't be positive 60, would it? Their product would be negative 60. Okay, so let's think about this. I actually might have made a mistake here. I don't know if we can do this one because, let's see, 15 and 4. So 60 has factors of 15 and 4. It can also be 20 and 3. It can also be, let's see, 12 and 6. No, 12 and 5, rather. 12 and 5. Oh, that must be it. So negative. So let's make this. So that's negative 17. It must be negative 12 and negative 5. So it's x minus 12 and x minus 5, because their sum is negative 17 and their product is positive 60. Okay. So positive 60 and 19. All right, so that's going to have to be the 15 and 4 factors. So we have x plus 15, x plus 4 as the answer there. So we have 60 and negative 23. So let's work with the 20. So let's make this negative 20 and negative 3. X minus 20 and x minus 3 should be the answer there. Okay, positive 17. So this is 17 and 60. So that must be my 12 and 5 again, but this time positive. Okay, now here I have 60 and negative 19. So let's go look back at 12. That's almost identical, except it was positive 19. Let's just make those factors negative and see where that gets us. Yep, the sum of negative 15 and negative 4 is negative 19. Their product is 60, so this is x minus 15 and x minus 4. Okay. And for number 16, okay, that's going to be 60 and negative 61. So let's make that negative 60 and negative 1. Okay, so it's x minus 60 and x minus 1. Okay. All right, so tomorrow we're going to talk about trinomials that have a lead coefficient that's not 1. All right, so right now you should be able to factor trinomials with lead coefficient of 1 into 2 binomial factors.